Coming up on Dr. Kiki's Science Hour, we're talking about a novella approach to medicine with Dr. Stephen Novella from Science-Based Medicine. That's up next on Dr. Kiki's Science Hour.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Dr. Kiki's Science Hour is provided by Cachefly at CACHEFLY.com.
This is Dr. Kiki's Science Hour with me, Dr. Kiki, episode number 63, recorded on Thursday, September 9th, 2010. Heal Thyself. Welcome, everyone, to Dr. Kiki's Science Hour. I am Dr. Kiki, and yes, this is the hour of science. It's a period of time where you just get to sit back, relax, absorb, listen to a couple of people talk about science, the things that they enjoy, and maybe you might learn something over the course of the hour. I don't know. I don't promise anything. I just have hopes. That's all. Just some hopes. Today, we're going to get down and dirty into the topic of science-based medicine. Now, you might think about that and go, medicine, isn't that science-based to begin with? Well, for a large part, yeah, there's a lot of science that underlies the medicine that we use to heal ourselves, to treat illnesses. But it's historically not necessarily all science-based. There's a lot of just observation, anecdote, stories that end up leading to just generally held beliefs about the way we should treat ourselves. And joining me today to talk about this topic is the highly esteemed Dr. Stephen Novella from the Science-Based Medicine blog. Thanks, Stephen, for joining me.
Hi, Kiki. How are you? Good to join you.
Yeah, doing really well. I was reading around today and, this week looking at a bunch of different things that are popping up online. And one thing that kind of caught my attention was this headline of pharma companies using ghostwriters to put marketing talk and put their marketing message into scientific literature. And I just kind of started thinking about that. I'm like, my gosh, really? So there are like doctors being hoodwinked out there. They're reading these articles and thinking that all the research is straight up, but it's not necessarily that way. Can you comment?
Yeah, this is a very disturbing episode. It's called, ghostwriting. Essentially what certain pharmaceutical companies have done is deliberately write review articles or commentaries or even case reports, etc., for the peer-reviewed literature. They write it with a very careful eye towards inserting very specific marketing messages, either downplaying side effects of their product or making claims for off-label indications that go beyond the evidence, or even trash-talking a competitor, downplaying the efficacy or safety of a competitor. And then they would give that to an academic or a physician who has some reputation or who has been published, what they would call a thought leader, and ask them essentially to sign their name to that paper. And how they sell that is saying that they just want to do the editorial work for this academic, just like a student would, but of course then the author, the physician, could make adjustments to it or suggest changes, but they're always careful to guard the marketing messages in the paper. So at the end of the day, you have what appears to be just a regular either review article or commentary by an academic physician that is going through the peer review process, but there are carefully crafted marketing messages inserted into it. And the major problem there is that this is all done without transparency. It's stealth marketing. It's exploiting the peer-reviewed literature in order to essentially make unregulated marketing claims. The FDA doesn't regulate what goes in the peer-reviewed literature, so it's really just a way of doing an end run around FDA regulations.
But how does this end up, these marketing messages, how do they really end up getting out there? I mean, are they so subtle in the review papers that the review panel, usually there are at least 3 scientists who review any article that goes into a scientific journal before it's published for its accuracy. So how is, this stealth marketing, I mean, is it just subtle? Is it not so blatant that are they putting enough facts in that the message gets out there?
Yeah, it could be very subtle. It does have to get through the peer review process, unless it's like a commentary. Commentaries are sometimes not even peer reviewed. Just an editor would review them. A review article would be peer reviewed. But if you can imagine, all you have to do is just be a little selective in which facts you report. You don't necessarily have to misstate facts. It's all a matter of emphasis. And even in review articles, the reviewers will give their opinion, make recommendations. Is this drug, for example, a useful drug to give for a specific indication, or would you prefer it over other options? There's a lot of judgment calls to be made often, and that's, in fact, why physicians often read these review articles. They want to hear the opinions of experts who have more experience than they do and see what they're doing. And here it's all being systematically and can be very subtly geared towards the specific marketing messages, basically getting physicians to prescribe more of a specific drug. The paper that you're referring to, which was published in PLOS One, was talking specifically about hormone replacement therapy, and the pharmaceutical company was Wyeth. There was a lot of documents that came to light as part of a court case, as part of litigation, documenting, over years this process of ghostwriting and essentially manipulating the so-called authors, into signing off on, what is essentially marketing literature.
I'm wondering also, there's a comment made by Dr. Mom in the chat room. She said any author who would agree to something like this is not ethical. So do you think there's an ethical question as well, just to having a ghostwriter?
Yeah, absolutely, but it's more complicated than it may at first seem. I mean, when academics write papers, often there may be 3 or 4 or 5 authors. There's often a primary author who does the first draft, but other authors will just, offer suggestions or do some fact checking or maybe clean it up a little bit. So academics are used to contributing to publications without necessarily writing every word. So that's not an excuse. I'm just saying that makes it so that if someone says, hey, listen, so we're going to be doing the role of the author who's writing the first draft, and we just want you to edit this for us and give us your comments. And, because we respect you, we'll let you sign off as the first author. If they should realize that there's something off about that's not quite right. But you could also see how they might convince themselves that it's legitimate because, and in fact, in addition to the companies that did this or farmed out the ghostwriting to medical writing companies, basically, that did this, they also specifically managed these authors, right? They knew what to tell them and how to coax them into doing this. But at the end of the day, they should have had enough savvy to realize that this is not legitimate, that they were people who were doing some of the writing who were not appearing as authors. So that's a bigger problem. It's not so much that someone is getting credit for writing the paper who didn't do the first draft. They are signing off on the content. It's rather that there are people who contributed to the writing whose names are not appearing on the paper, and therefore they do not have to reveal any conflicts of interest. Right. You might imagine that someone reading a paper would think about the content very differently if the lead author or one of the authors said, I'm a paid consultant for the pharmaceutical company who makes this drug. That at least would put you on notice, give you fair warning that there's a conflict of interest there. So it's this stealth aspect of this, the fact that the authors had an agenda that is not apparent to the reader because their names and their conflicts of interest are not appearing anywhere on the paper. It's very deceptive.
Yeah, and I think that the conflict of interest point and not being responsible for any of that or any of the outcomes that are related to what you write. I think that's a huge aspect of it. There are a few people, Mark Pelletier and Dr. Mom, are a couple in the chat room right now who are saying like, oh, we argue about every single word, and I don't sign off on anything unless I know exactly what's in the paper. So, there is that personal responsibility to the words that are being written and the information that's being published. From this article that's come out of PLOS, though, are there any examples yet? This is just, breaking as, okay, Wyeth has been doing this, hiring the ghostwriters. We know that there is this stealth marketing taking place. Are there any examples yet of physicians coming forward and saying, wow, this is I read these papers and they completely, changed the way that I started prescribing medications, or they affected the way that I treated my patients? Is there anything coming out in that way that could potentially be negative at this point yet?
Not that I've heard of, although I guess waiting for that kind of information to come in.
Yeah.
I mean, this paper was based upon 1,500 documents that were released as part of this litigation, and there it was documenting it from the pharmaceutical company end, basically saying how they manipulated the process and managed the writers, the authors rather, and how they protected their marketing messages. It was all very manipulative and callous. But in terms of the physician end, saying this paper had an influence. I mean, the example in the paper itself is the hormone replacement therapy, and the point that they made was that there were a lot of physicians prescribing these hormone replacement therapy based upon these marketing messages, these stealth messages that were inserted in the peer-reviewed literature. So, of course, the whole point of this is to have an influence on prescribing practices.
Exactly.
Yeah. So it is, outrageous. I mean, I think that, I'm never one to bash big pharma or make them into a villain, but they're corporations and they're in their business of making money, and we do need to carefully regulate them, otherwise they'll do stuff like this. And this is, in my opinion, completely unacceptable. I mean, science-based medicine has to defend its transparency and its legitimacy. I mean, there's a lot of assumptions that go into articles that are published in the peer-reviewed literature, that the authors are being honest and transparent, and that they don't have any conflicts of interest that they're not disclosing. So this violates that. It violates the basic assumptions of the peer-reviewed literature. And definitely steps need to be taken, I think, on multiple levels. I think the FDA has to look at their regulations and maybe see if there's existing laws they can use in order to stop this behavior. Maybe they need new powers to be able to do it. Universities and also editors need to be more aware of this practice and put steps in place to keep it from happening. I think it just has to be academically completely unacceptable to sign your name to something that other people wrote, the real authors are not being disclosed on the paper. That is unacceptable.
Yeah, I think that where it needs to start is in the academic institution. Unfortunately, the academic institution, for the most part, abides by these rules. It's the corporate institution that may be more difficult to convince. And so how do you get the science publishing process to actually change, to get people to say whether or not there's any unnamed individual who actually had a hand in crafting the article? How do you get that information out of somebody who doesn't necessarily want to disclose it?
Well, remember, there always has to be the person who is the front man, right? The academic who is signing off on the paper. And perhaps, your question holds the answer in that, an author needs to sign off on a lot of ethical statements when you submit a paper. You put your name on the paper and you sign a bunch of disclosure forms that say that you contributed to the paper, sometimes even detailing how you contributed to it, and again, your conflicts of interest, etc. So just simply add to that, to your knowledge, no one contributed to the writing of this paper that's not listed as an author. Right there, that would be, it'd be hard to ignore that. That would go from turning a blind eye to committing direct fraud, which
right.
I think would end the practice. It may be just doing that alone would end the practice.
Yeah, I think this is just in general, this is a really interesting question. The publishing of articles coming from drug companies versus coming from academic institutions, and where you think that it's kind of a self-reporting, self-verifying system as it is, and you think, okay, it's a trust-based system for the large part at this point in time.
Yeah,
right?
there's certainly it's hard to completely remove the trust element in the scientific process, and peer review really isn't designed to weed out fraud. I mean, if you are going to lie and commit absolute fraud, then there's nothing in the peer review process that will demonstrate that will reveal that. Most people who commit scientific fraud are exposed because either they confess or because somebody who worked very close with them confesses. It's not because a peer reviewer detects the fraud. I mean, if you're cooking the numbers, then then there's I don't know how a peer review process would reveal that.
Yeah. Unless you have to disclose all of your data, your raw data, to be able to. I mean, but if you're cooking your numbers from the very get-go,
right?
How are you going to actually figure that out without actually going to somebody's lab and going and finding documentation? So it comes down to the point of there's a point where you have to trust that researchers have done the work, that this is actual data, that everything is. Otherwise, you're going to have a crazy monitoring system in place.
Yeah, I think we always need to think of ways to minimize fraud. I mean, one of the ways that the system deals with that is with replication. Maybe one researcher, one lab is committing fraud, but generally, probably not. Many different independent labs are probably not committing the same fraud. So, no one study should ever be thought of as definitive. It needs to be independently replicated, and that weeds out fraud. There are also ways of analyzing data statistically. Cooked data doesn't have the same kind of distribution, generally speaking, as genuine data has.
Right.
So there are ways of analyzing data to see if there's a systematic bias or maybe a conscious bias in the data. But I don't think that's routinely done. Maybe that does need to be a little bit more routine, and journals need to employ statisticians who routinely review data, raw data, to make sure that there are no red flags are brought up. And then if there are, they can then request to look at original data, like the raw books or wherever things were being recorded. That's a laborious process. It's a lot easier just to trust the researchers and then hope that the occasional fraud's not causing too much havoc than to put in an elaborate system that requires a lot of resources. But I think we do need to think about ways to minimize that, because it's always disastrous when it happens. I think the direct impact of contaminating the scientific literature with fraudulent results tends to be fairly minimal because of replication, et cetera. If something is not true, it won't sustain itself under scientific research. But what it does, the biggest harm I think it does, is it cuts right to the public's faith in the institution of science and medicine. In the case of science-based medicine, it's hard to be out there defending science when there are people undermining its credibility with fraud.
Yeah, and how do you continue to trust the people or the institution if fraud is something that is being brought to the surface? And that's something that's been really interesting recently. It just seems that with science becoming more open, with more people blogging, with more people actual scientists talking about their research, people putting news that they've heard out into the web. It seems like reports of fraud are much more common. I don't remember hearing about prominent researchers like Mark Hauser recently. I don't remember hearing about prominent researchers being put under investigation by their universities as often as I have for over the last 10-year period. It seems like things are increasing, or at least the visibility of those things are increasing. And so how is that going to affect the entire trust of the scientific institution?
Yeah, I agree. I don't know if it's a real increase or if it's just the visibility. I think the visibility of everything is increased because of Web 2.0, because of blogging and podcasting, et cetera. And I do think that, one very good thing that has come out of that is those researchers and scientists who have the desire and the talent and ability to communicate with the public in whatever medium they choose are doing that, and therefore we have a lot more discussion directly between scientists and the public. That's all a good thing, but it's also exposing the dark underbelly, of research and science. Ultimately, short term, that may produce some uncomfortable exposés, and it might harm the public's confidence in science. But I think long-term, it's a good thing because we're getting it all out in the open, the good, bad, and the ugly, and we'll work through it. And then when people, I think, get over, maybe a bit of a naive sense of pristine science, they realize that science isn't pristine. It's done by people with all the frailty that people have. But that it still manages to muddle forward. It still works despite all its flaws. Then you get to a more mature acceptance of science that's not so frail that it will be threatened by every exposure of fraud or misconduct or this kind of thing.
You mean if people actually understand the scientific process, it might lead to just even bigger and better things?
I think so. I mean, if science has a lot of warts, so does every human endeavor. When you really learn how things operate on the inside, you realize that it's just any human institution is full of all these things. It's like, if you ever saw how legislation is written on Capitol Hill, I'm sure the average person would be appalled. That doesn't mean the system doesn't work. And what I hear a lot, actually, is people who hear about some of the failings of the process of science, and they're shocked and stunned, and they think that invalidates all of science. It's like, no, that's just that's just how science works. But we work through it all. It's messy, and there's a lot of waste and confusion. But in the end, if something is actually true or actually works, that has a distinct advantage in the scientific process. It gets really hard to maintain a fraud or a lie because they just won't stand up long term under replication and duplication.
Yeah, and I think that's a major aspect of it. The actual process and what scientific evidence has to stand up to over time, being the repeated testing of hypotheses, of ideas, to be able to make sure that they actually all are right, that they're accurate before moving on. Or you move on, and in the process, you retest things and find out, oh, wait, that didn't work. We have to go back to the drawing board. And so there's this constant, 2 steps forward, 1 step back, or even a few more steps back before you can go forward again. There was an interesting point brought up by Mark Pelletier in the chat room about peer review and the possibility of using a crowdsourcing for peer review. And if you can put papers out to the scientific public to be reviewed, so are there going to be 10, 100, 1,000 people reviewing a paper? If all those people review a paper, how does that change the accuracy of the information that's out there?
Yeah, I wrote about that recently on Science-Based Medicine, that exact thing, that we are entering a period where journals are reconsidering the very process of peer review. And this, crowdsourcing, at least among experts, if not, the public at large, I think it's a great idea. I mean, you're otherwise you're relying on somewhat of a haphazard process that the few people you choose to peer review are going to have the proper perspective and background knowledge and are just going to pick up on things and are going to have the information at hand to weed out error or maybe add elements that are missing. But if you have 1,000 people or 10,000 people doing that, then the chances are you're going to cover all of the ground, right? You're going to pick up everything that needs to be picked up. I still think there needs to be some kind of editorial process, and maybe you do need to have at the end a few experts, putting it all together. But having papers pass through a period where there is either a public or a semi-public crowdsourcing phase, I think would add a lot of quality to the scientific papers that are getting published. I think a lot less, a lot fewer mistakes will slip through the cracks with that process. The question now is how to do it efficiently.
Right. Yeah. And I think that's something that people are going to be working on for quite some time to come. It's not going to be an answer overnight. I know there have been some. There are some online journals and different groups that are trying to have crowdsourced commenting or bringing that comment system into publication, and it hasn't taken off. There are a few papers that garner a lot of attention, but the majority of papers don't really get that many comments, don't get that much critical assessment. So at this point in time, from what's out there, it doesn't seem like that crowdsourcing within the scientific community either is getting enough attention, either has, there's no reason for people to do it. At this point in time, the scientific institution isn't open enough, really, for it to be on a young scientist's to a young scientist's benefit to be spending their time commenting on these on papers. So the system itself still has a few bumps that need to be figured out if it's going to work, but it doesn't seem to be taking off yet.
Yeah, we're in the experimental phase right now. I think this is a time for open experimentation, and it's hard to predict human behavior. As you say, it sounds like a great idea, but then maybe people just won't do it. There won't be the incentive to do it, or maybe the profile is just not high enough. Or in my busy day, why would I say I think I'm going to spend a half an hour now crowdsourcing random articles?
Yeah.
How does it work into your busy academic day? What's the incentive, or just what's the prod?
Less sleep.
To do it? There's got to be some payback.
Drugs
right?
to keep us from sleeping.
But people need to think about this and to keep experimenting, trying new things, and then we'll hit upon some things that work. But the first person to figure that out will get the credit for it, right?
Yeah, absolutely. So I want to switch topics here and move on to away from kind of the scientific peer review topic and how this stuff is getting in there, and talk for a second about AIDS research in Africa. It was a topic that you wrote about both on the Science-Based Medicine blog and your neurological blog. And there were some really interesting points that I think that you brought up on the numbers of feet on the ground. So trained medical professionals on the ground in Africa versus the witch doctors. Mm-hmm.
Yeah, it's a really interesting problem. So, as many people know, Africa has an epidemic of HIV/AIDS. It really has run rampant in that continent, and they do not have the resources to deal with it. They simply don't. They're getting a tremendous amount of foreign aid to deal with the AIDS problem there, but it's not enough. They simply do not have an infrastructure of modern medicine, of 21st century medicine. What they do have is traditional healers. And like many developing countries that don't have a science-based or a modern healthcare system, they rely a lot upon traditional healers whose practices are not necessarily of any health benefit, or maybe there are some basic things that they do which are helpful, but they're intermingled with a lot of superstition and tradition that's not based upon, any real helpful practices. So the dilemma is, do we utilize these traditional practitioners in the fight against HIV and AIDS in Africa? Now, the World Health Organization is doing just that. They are beginning programs that are seeking to educate and train some of these traditional healers with some information about HIV and AIDS, how to prevent it, how to prevent the spread, how to treat it, using them as a portal to get the public to buy into the modern treatments that the foreign aid is paying for, or that the infrastructure that is there is trying to hand out. The problem with that is that we have to decide if we can get these traditional healers to buy into it. Their position and their station is based a lot upon their mysticism. Often, their traditional practices. So they may decide that it's not in their interest to go against that, or to embrace a new system that
Right.
the public doesn't buy into. So again, it's one of those things where I think it's reasonable to think carefully about it. I apologize for the phone keep ringing in the background.
It's okay.
And to try to decide how to best exploit that resource. But my take on it was that I think it's a double-edged sword, and it could easily backfire or become counterproductive if the process is not very carefully thought out. We could essentially empower or lend credibility to people who are then going to use that support. I mean, they already have basically a lot of the public support, but they would have even more to then spread practices that are harmful. For example, a lot of traditional healers will prescribe local herbs as remedies for things like AIDS. And they, herbs are actually drugs, and they can certainly have drug-drug interactions and interfere with the effectiveness of actual HIV medications, for example. So that's just one example of things that traditional practices that could be counterproductive, and we certainly don't want to inadvertently spread those counterproductive practices.
Yeah, and that's a huge concern. And so how do you go about, you have a problem with the number of people that you have medically trained that are there now currently and able to give help. How do you get them to then train traditional healers and get the traditional healers to give up their training or to think a different way about how to heal somebody? When normally they would say, okay, take these herbs, and the person at the same time is possibly taking, anti-HIV medicines.
Yeah.
Or even just taking herbs that aren't going to have any effect on their health overall. Maybe bring down a fever, but that's about it.
Right, so it may replace more effective treatment, it may interfere with that more effective treatment, and it may even be directly harmful. I mean, there are stories about traditional healers doing, prescribing treatments such as dousing people with cold water and having them stand out exposed to the elements as a treat. Or and obviously there's also a lot of very, very harmful myths spreading throughout the continent. There's still this widespread belief that if you have sex with a virgin, that will cure you of AIDS. So imagine how counterproductive that is.
Yeah.
That's causing, obviously, just increasing the spread of the disease even further.
Yep.
So these things need to be dealt with. And some of the feedback I got after I've written about this indicates that to a lot of the population there, the science that is being imported from the Western world, to them, is just another form of authority and magic. They don't distinguish between one authority figure saying, take these pills, and another one telling them to do something different. They don't distinguish necessarily between traditional mysticism and science-based medicine. To them, it's all pretty much the same. So there isn't really a lot of cultural buy-in, again, in the rural areas and in the areas that are not more exposed to Western culture. So it's a really difficult problem. But I think the WHO, the World Health Organization, is a bit desperate. They know something needs to be done, and doing nothing is certainly not an option. So it seems reasonable to experiment with these other options. My hope is that they're not going to go in with their eyes closed, right? That they're not going to be naive and think that all they need to do is hand out pamphlets or train these traditional healers and it'll all work out great. They have to have an eye towards the possible unintended consequences or downside of this, and then mitigate it or take steps to deal with that when it crops up. Otherwise, they could easily do more harm than good with a program like this.
Yeah, I tend to agree with you, especially if they don't take into account the attitudes of the patients, of the people who would be treated. So you might be able to take in the attitudes of the healers, but then you also have to, combine that with how are the patients going to respond to the healers versus Western medicine versus, I mean, is it really the same in their head, or have they had do they have a lot of reasons to distrust Western-based medicine? And so are they going to push that away and go to their healers even more? So there's some very, very sensitive issues to be dealt with.
You can't change culture overnight. It has a lot of inertia, and we have to. I do think that we also can't just import our Western medicine and think that they're going to accept it with open arms. In fact, we remember the episode in, I believe it was Nigeria, where local preachers were preaching that the vaccine. I'm blanking on the name now. The polio vaccine. I'm sorry. Yeah, the polio vaccine was spiked with AIDS, and that if you took the vaccine, it would give you AIDS and make you sterile. And that's what the people were being told, that it was just, it was an insidious plot, from the West, from America, in order to make their population sterile and infect them with AIDS. So compliance with the polio vaccine plummeted, and that led to an outbreak of polio in that country. We were on the brink of eradicating it from the world, and that stopped it. And then it spread to other countries. And now by addressing that rumor, by addressing those false beliefs directly with the people and also with the leaders, with the preachers who were spreading it in the first place, they've been able to get public buy-in again to the polio vaccine, and they're starting to make progress again. So our best intentions and our best medicine will do no good if we are not confronting the beliefs of the person in the street and the beliefs of their authority figures. We need to get them on board, but we have to realize that that's the game that we're playing. We have to convince those people first, and we can't assume that they're just going to buy into whatever we tell them.
Yep. And for a final conversation point, I was hoping to jump into the idea, I guess, of statistics and how statistics are being used in medicine, science and medicine. Recently, there was an article on, let me see if I can pull it up here. There was an article that made it around the web a couple of weeks ago talking about how youngest kids in kindergarten were more often diagnosed with ADHD, and did this lead to an overdiagnosis of ADHD in kids? Do we have an overdiagnosis of about 1 million kids in the United States? And this leads also to the question of, are these kids taking ADHD drugs? And, how did this, how accurate can this study be, and how can we use information like this to actually inform the way that we test for ADHD, diagnose for ADHD? And this is just one specific example, but there are probably many others.
Yeah, this is an interesting example. I mean, this has been a question for decades. Are we overdiagnosing ADHD? It's actually been looked at many different ways. The consensus is that we're actually not overdiagnosing it. That if you look at kids who are diagnosed with ADHD and then you subject them to a rigorous diagnostic process, they actually most diagnoses are actually fairly accurate. The rate of overdiagnosis is about the same as the rate of underdiagnosis, actually, which we expect there's always going to be a certain amount for any diagnosis that we try to make. ADHD is particularly challenging because it's a clinical diagnosis, right? There's no biological marker. There's no blood test for ADHD. So there's a more clinical judgment and experience involved, and there's also more fuzziness around the edges, right? You always have to decide, where the limit of the normal behavior is, right? There's always, normality is always, from a health point of view, always exists on a bell curve, right? So largely, we use statistics to decide what's normal. You have a bell curve of variation. You take 2 standard deviations, that's normal. And everything outside of 2 standard deviations we call abnormal. But that's completely arbitrary. For something like ADHD, we're doing that for a number of different features. So there's always going to be fuzziness around the edges of any diagnosis like that. ADHD also has a separate challenge, which is the very one that came up in the study that you're talking about, and that is it's a moving target that kids of different ages have different ranges of what's normal. Right. What's normal for a 5-year-old is ADHD for a 7 or 8-year-old, and that was the problem I think that they were identifying in that paper. But that's the endless process of refinement that occurs in science and in medicine, right? You have diagnostic criteria. You can't study every single aspect of it. There's almost an unlimited number of permutations or different ways of thinking about or applying, different diagnostic criteria or different interventions. And so, when someone says, hey, let's see if these criteria that we're applying to kids, work when you apply them to younger kids, you might think that it would lead to overdiagnosis because younger kids it's more normal for them to be hyperactive. Yeah. And so it's not surprising that that's what they found.
Yeah, so basically the results are not that surprising that these younger kids are more likely to be diagnosed with ADHD if age is not taken into consideration.
Yeah, again, the studies are typically done on some test population, and one of the questions you always have to ask is this population representative of the broader population? Mm-hmm. So we may do studies in men and then have the question, does this apply to women? Or we do studies in adults and we want to know if it applies to kids, or we do it in older kids and then we need to know if it applies to younger kids. Or we may test a healthy population and not know if those results apply to a population with a variety of different chronic diseases. You could never study everybody with every possible permutation, so we're always extrapolating beyond the study population. And that is exactly what statisticians and experts in doing clinical trials study. That their job is to ask all these questions about what do the numbers mean, where do you draw lines between normal and abnormal, what criteria do you use, are these results statistically significant, and how does this apply to the real world? That's it. These are never-ending questions that we're asking about all the kinds of data that we use to make clinical questions, because medicine is an applied science. We have to actually make decisions in the real world, and we're always faced with decisions that go beyond the precise evidence that we have. We're always extrapolating from limited evidence, and so this is, again, as I said, this is an endless process of extending our ability to do that, to apply our data and our evidence to the real world populations.
Yeah, I'm wondering, it's been said a lot, it is a process to be able to understand how to extrapolate in a meaningful way. People say all the time, you can prove anything with statistics. You can make anything come out in your favor if you use statistics, if you know how to use statistics. Do you think that's true?
Well, if you are willing to abuse statistics, sure. The implication there is that if you are systematically biased, then you can keep working the numbers until you get a result that you like. That is generally true. that doesn't mean that you can legitimately apply statistics and get any result that you want. That's the whole point between good statistics or legitimate statistics and the abuse of statistics. And that's another reason why we need things like peer review. This gets back to the discussion at the beginning of the show, why sometimes it can be very subtle. That distorting data could be very, very subtle. The type of analysis that you use, the type of inclusion and exclusionary criteria that you use. There's a lot of decisions that you make. Sometimes probably the most subtle thing is there may be multiple legitimate ways to statistically analyze data, but you're supposed to choose the way you're going to look at the data before you have the data, right? You say, this is the best way to look at the data, and then you collect the data, or then you actually are exposed to the data. But let's say you have the data, and then you decide which way to statistically analyze it. That gives you the opportunity to analyze it 5, 6 different ways and pick the one that works for you. So that's a really subtle way to cherry pick data just by choosing how to analyze it after you already have the data. So that's one of those subtle things that reviewers know how to look for, and a good paper will disclose that these methods were determined prior to data collection. That's the kind of thing that is conspicuous in its absence if you know to look for it. But the average person wouldn't necessarily know that that's a really subtle way to distort data by choosing how to analyze it statistically after the fact, because it's not always obvious what the best way to analyze the data is. And there's lots of really subtle and convoluted and complicated ways to statistically analyze data. I'm not a statistician. I don't always understand it. I have a basic working knowledge of the different types of analysis, but I wouldn't know when to choose a one-tailed test versus a two-tailed test. I mean, I rely upon the experts to make that decision. And again, you just hope that they're an honest broker, and that they're transparent, and that they're making good decisions, and that that peer reviewers who also know statistics are double checking them. But the number of opportunities to cook the data by using legitimate statistical methods, but just applying them in a specific way is huge, and that's again why the peer review process is so important, because otherwise you really could it is true in a way that if you had all of these statistical tools at your disposal and you really knew how to use them, you could almost make the data look any way that you want to.
Coming to the end of the hour, and I'm, people see statistics all the time. People, stories come out in the news, and I'm looking at some items on your blog, Neurologica, that are just really interesting and are good examples of how do people use information they see in the media to make informed decisions. So, for example, just scrolling down, you have a story about dementia and doing mental exercises. There's a story about B vitamins and mental decline, alcohol and survival. That's something people always want to know. How much can I drink and not damage myself too much? There are lots of studies about, aspirin. How much aspirin do you take? Organic food. Is organic food better than conventional farming? There's so many things for people to make decisions about today. How do people take the glut of information that's out there and process it?
Yeah, it's overwhelming. And I do think that both as individuals and, I think as institutions and society, we do need to think about this. Unfortunately, if you read my blog, you also probably will see one of the common themes there is that the media generally does a terrible job of reporting these. I think every one of those stories you mentioned, there's always a section there about how it was completely misreported in the lay press. And I think that's really a serious problem. We're having a shortage of good science journalists. I think a lot of general journalists are taking over the science beat, if you will, as traditional journalism outlets are downsizing. So the quality of science reporting is going down. I'm hoping that science bloggers, scientists actually blogging and podcasting, is taking up the slack and maybe even doing a better job. But for each of those issues, I mean, it's hard. it takes me a long time sometimes to like really wrap my mind around the evidence and decide for myself, should we be prescribing B vitamins for dementia? Is organic food better or not? Sometimes I take a long time to really decide for myself if I think that, where I think the evidence lays. And I rely upon other experts, to summarize the research quite often. I think, there are some rules of thumb. If it's really important to you, invest a little bit of time trying to understand it. Read multiple sources. Don't believe the lay media. The lay media does a terrible job of reporting science. Try to find some scientists who don't have some obvious conflict of interest, like they're trying to sell you something, and see what their opinion is. If there's a controversy, then I would say take a more cautious approach and try to understand what the other side is saying. That's one thing that I do. I always seek out the opposite opinion to the one that I initially encounter or the one that I may hold myself, and try to find what's being said on the other side. And that's a good way to get a quick feel for a controversy. If there's really nobody arguing on the other side, then it's probably a reasonable consensus. If you can, and that's the good news is you could do Google searches, and if you're a little bit more savvy, PubMed searches, and you could pretty quickly find out what the other side is saying. And again, that's a good way to sort of cut to the bottom line of how sure are we about this, or is this still an ongoing controversy? And are there any institutionalized recommendations? Right? Has some professional organization like the American Academy of Neurology, have they come out and said officially, this is what we recommend based upon the evidence? Those are usually pretty well established if they're willing to.
Unless it's the American Chiropractic Association.
Well, yeah, of course, the institution itself has to be legitimate. I mean, I wouldn't listen to institutions that themselves are controversial because they say all kinds of crazy things. But I wish I had the quick and easy fix, but the bottom line is you have to invest time. It's a lot of work, and there's no easy answer. There's a tremendous amount of misinformation out there, unfortunately. You just have to get good at finding sources of reliable information.
Yeah, I tend to, I definitely agree with you, and it takes work. And usually, if it sounds too good to be true, it is.
It probably is.
It probably is. You'll probably find there's a whole backstory there that you're missing, and there's a lot more information that needs to be gathered, or there's a whole conversation that is taking place that you need to take into account.
Right. Exactly. I agree.
Yeah. This has been really fun, Stephen. It's great having you on. You've got such I really enjoy talking with you about these subjects. It's great.
It's always a lot of fun, Kiki. Always great to talk to you.
Yeah, you too. So, Stephen, where can people find you online? You're around and about the internets.
I am. So I am the senior editor of ScienceBasedMedicineorg, which is a group blog. We have more than a dozen physicians and professionals blogging there every day. It's a very high quality outlet. Very good source of information for any health information. I have my personal blog where I'm a little bit more far-ranging in topics, not limited just to health topics, and that's Neurologica, as you said. I also collaborate with another group blog called Skeptic Blog, which takes on more skeptical topics. And probably my biggest outlet right now is The Skeptic's Guide to the Universe, which is my weekly science podcast.
Which is a great podcast. I know, it's very well listened to. And there's a good reason for that. You always talk about just great topics, and you have a good group of people together to discuss them. So
it's a lot of fun.
Yeah, it's just great. And I love the new, I know it's not new anymore, but the new look to the website.
The website, yeah.
Yeah, it's awesome. What brought that on? Right.
It took a year to hammer that thing out, so I don't think we're going to be changing it anytime soon. It's good enough for now.
Yeah, I love it. You've got media, store, you've got events, blogs, links to different, the blog feed for the different SGU members. I think it's a great resource for information. I'm sure there are some people out there who will be like, skeptics, what? But,
It's mainly a science podcast, but we talk about controversial issues, and we just have a lot of fun with it. I mean, we really try to be as entertaining as we are informative.
And you are that. I definitely think so. Yeah, you're welcome. Well, thank you so much for joining me. I really appreciate you taking the time out of your day to talk about these topics, and I hope that we covered some ground that gave people out there some fodder for thought. And if anything, that's all I hope for. People start thinking about stuff a little bit more deeply.
Exactly.
Yeah.
Well, anytime, Kiki. It's a lot of fun.
You're welcome. And are you up to anything new that we should be aware of?
I don't have time for anything new. I think I'm busy enough. Going to be in Australia at the end of November. So if any Australian listeners will be at the TAM Australia in Sydney. That's the next big event coming up.
Great. All right. So people, if Australians out there, keep an eye out for Dr. Novella. I'm jealous. I want to go to Australia.
We're looking forward to it.
I want to rack up those carbon, not credits, deficits.
Carbon footprint. Yeah.
Carbon footprint. Yeah. I got to find a really good reason to go to Australia, like TAM, or I don't know, snorkeling on a coral reef. That could be good too.
Right. I'll plant a tree.
Okay, good. Offset. All right. Thank you very much, Dr. Novella. For those of you who missed it, you can find him at theskepticsguide.org, at his neurologica blog, which is thenes, THENESS.com/neurologica blog, and also at Science Based Medicine, which is ScienceBasedMedicineorg. And for any more episodes of this show, you can find this show at twit.tv/Kiki. You can find me all over the web. I'm Dr. Kiki, Twitter, Facebook, Google, email, all those things pretty much. Dr. Kiki, I'm there. And you can also find me on This Week in Science, which is twis.org. Thank you very much for listening, and I do hope that this hour of science learning has made your world a whole lot more interesting.